All right, so my name is Billy Hoffman. Some of you guys might know me as Acidus. I've spoken at a lot of conferences over the past couple of years on a wide range of topics. Today I'm here to talk to you about covert crawling, which is basically a mechanism of how to use an automated process to crawl a website and gather information without leaving a forensics trail. I tend to talk a lot and really fast. So if you have a question, please feel free to interrupt me. I have fun swag that I brought. I've got some bag from when I spoke at ShmooCon and some, whoa, that would have been bad. Some stuff from Black Hat Federal and stickers and stuff. So if you have a good question, you get swag. If you have a bad question, we ridicule you. That's kind of how it goes. All right, you guys ready? Yeah. All right, cool. So what am I going to talk about? We're going to go through and first start talking about what is the state of web application attacks. We're going to go ahead and talk about how a covert crawler pretty much kind of changes the equations on how attack and defense of web apps works. We're going to talk about the obstacles it took to create a covert crawler. Specifically, how do you make an automated program act like a browser? How do you make an automated program act like a human? And how you throttle one of these things. We're going to talk about how I actually implemented a covert crawler. And it says questions, but like I said, ask me questions the entire time. OK, so State of the Union. How many people here have ever hacked a web app? How many has ever thrown like a single tick or something into a search field to see if you get a SQL exception or all sorts of fun stuff like that? You know, hacking websites is really easy. I'm sure a lot of you read BugTrack. Like something like 70% of the vulns I've been reading on BugTrack for the last several months have all been web app attacks, SQL injection, cross-site scripting, misplaced trust, improperly, created SSL connections, all sorts of nasty stuff. They are laughably common to find. I found a cross-site scripting vulnerability in weather.com this morning when I was trying to figure out what to wear. So it's crazy. They're all over the place. People are hacking websites because it's in the news. There was this awesome attack on MySpace back in October. Somebody actually wrote a cross-site scripting virus, which used Java code and Ajax to propagate. There's someone here who was doing cross-site scripting stuff. Ooh. So this was an awesome virus that used Ajax to actually propagate itself and infect more cross-site or more of MySpace. I actually gave a presentation at Black Hat Federal about web app worms, and so if you're interested in that, come talk to me afterwards. People are hacking websites because they can make money. Attacking a web app gives you the same payload and the same take as doing, say, a layer 3 or a layer 4 attack. You're trying to gain access to systems you normally don't have access to grab passwords, credit card data, confidential information, identity theft. Anything you want to do, you get access to the information through a web app just as easily as you can get access through a anonymous account on FTP. So administrators are patching some of the holes, pretty much the PHP whatever the hell exploit of the week, because seriously, I love open source, I use open source, but God bless SourceForge and all these PHP projects because they completely keep my company in business. So, but that's why I come and I talk to you guys about how to actually write secured web applications. So it's a give and a take. A lot of times people rely on their logs if and when they get attacked. They're like, oh, crap, somebody totally just dumped my entire SQL database out. Let me go to my logs and see who was connecting to me a lot. Normally they contact the IP owner, which is almost always an open proxy that shouldn't have been opened in the first place. And then the two people go after the attacker with limited success. So whether you're actually sneaking a web app attack by an IDS or an IPS is debatable. There's some pretty cool attacks. Dan Kaminsky actually had a really neat timing attack with IP fragments so that an IDS would see a regular, HTTP get, index.html, and the web server saw, get SQL injection attack. So, there are ways around IDSs, but the point I want to try to attack here is that attacks just don't happen out of thin air. People recon sites ahead of time. They try to say, I want to attack this bank. Let me start analyzing and let me start pounding on this bank a little bit, do some reconnaissance, and see if I want to actually attack them. And a lot of times, forensic people will tell you it's this reconnaissance they're able to see in the logs. And that's how they're able to track people, because people will almost always launch attacks through proxies, compromised machines, botnets, open access points. But almost always, they do their reconnaissance from their home machine. And so administrators rely on these server logs to try to find this initial probing. Sometimes they can actually see, wow, I normally get each visitor on my website hits like 10 or 15 pages. This one visitor, which isn't a bot from a search engine, hit all of my pages. I wonder if they're trying to scope me out. And so they'll proactively put a rule in their IDS or their IP tables and say, don't let this person come back. So why would someone even perform reconnaissance? Well, running a straight audit of a web app, if you're not allowed to, really isn't practical. It takes a very long time. Our product, I work for a company called SPI Dynamics, and we make products that scan websites for vulnerabilities. It takes something like 4 days to run all of CNN.com, which is excess of 800,000 pages. It's way too much network noise. Do you know what our bandwidth bill is when you scan CNN? It's pretty big. Reconnaissance definitely provides information about what you can, use for your attack. Version numbers about what technologies are using. I love looking at HTML comments and seeing I'm using, this version of VBbold or, PHPBB or whatever. It lets you know about the structured layout of the site. In HTML comments, you can find developer names, email addresses. You can do your traditional reconnaissance stuff. Go hit Google Groups and see what, if they're making posts to Usenet. Also, it provides a subset of pages you actually attack. Let's say CNN. That's a good example. 800,000 pages, right? Well, CNN only has a couple of interesting pages. They have a search page. They have a page for email alerts, which, by the way, is cross-site scriptable. They have, I totally send my mom, news stories, on her birthday. It says, Billy says his mom is the greatest in the world, and it's written by, Bob Woodward. Because you just, use SQL injection and insert a story in there. It's fun. You guys should do it. It's kind of like sending an email. Well, the reason I say you should do it is that you're not actually injecting it into their backend database. It's what's called a reflection cross-site scripting attack. So you're actually not exploiting or technically breaking any hacking laws. It's kind of like sending an email to yourself from God by finding, who hasn't telnetted to, port 25 and sent emails to people. It's like that. It's fun stuff. So again, like I said, it lets you know what you want to attack. Oh, they got a search engine. Oh, they got an email alert system. Let's focus on those instead of hitting all their news stories because those tend to be the same. So you can browse the site by hand in a web browser. That's certainly a type of reconnaissance. It lets the user kind of direct where they want their search to go. When I'm looking at a site, I immediately go to search engines, things like that take user input. You can mess with the query string, but it lets you kind of target it as opposed to a crawler, which is stupid and hits everything. The problem is it takes the time that the user could be using to do other things, like read /dot 10 times a second. And it's certainly not an exhaustive search of the entire site. It's very possible that while I'm only focusing, say, on the search engine aspect of CNN or the alert of the stock ticker, I'm not focusing on this, survey, which happens to be embedded inside every 10 news stories or something like that. Maybe that's vulnerable. But I didn't even look there because I wasn't exhaustive. Automated crawler is the complete other end of the spectrum. wget, I wrote some Perl script. I hit every single page. However, and so I exhaustively find all your vulnerabilities, which is what our product at SPI Dynamics does. But of course, I didn't come here to tell you something. I came here to talk about web security. So very obvious in your server logs if a crawler hits you. First of all, it's from one IP. You can also see exactly what they hit. So you can be like, oh, thank God, they aborted their crawler right before they got to my super secret vulnerable to SQL injection and dumped my customer database page. Thank God. So covert crawling is the best of both worlds. And of course, Beetle, you already know this. I gave this presentation at your conference. Of course, you were running around like a chicken with your head cut off. So. Ooh, ouch. Thank you. All right. So covert crawler really is the best of both worlds. It's all the pros of automated crawling. All the prawns. Get some shrimp, some prawns, some crabs if you go about 3 streets that way and meet someone unsavory. So exhaustive search, it's automatic, saves the resources for later analysis. Awesome. It also uses various tricks to make the crawl appear as if actually hundreds of different users were crawling your site. From different IPs, they only browse certain target parts of your website. So it doesn't have a giant bandwidth spike, so to speak, when they go visit their AW stats page. Now, this is not actually used for attacking the site. As I said, whether you want to try to employ the libwhisker, I don't know if you all heard of it. It's rather old, but it's kind of traditional mechanisms to avoid IDS and IPS things when you're attacking web apps. I don't even want to try to cover that. Let's just focus on finding things. Because if I can crawl your entire website without you knowing and find a couple of things that look interesting, I can go through an open proxy. I can go to an open access point. And I can spend 2 minutes hitting those 2 pages and hacking you as opposed to spending several hours crawling an entire site. So the beautiful thing about this is that you can later use IDS techniques, like I said, and also the logs are unable to show the reconnaissance happened because there isn't a single IP address that everything came from. Now you all are going, open proxies, it's no big deal. It's a lot more complicated to write a covert crawler than just simply spanning it across multiple IPs. So something I get a lot when I talk about this is, why don't you use a search engine cache? I mean, if you want to find out about someone's page, just use the Google cache. This is a really bad idea because the HTML comes from the Google cache, but the HTML has references to images, objects, scripts, all of those other things on the original site. So if I'm the administrator of, good.com, I suddenly see all these requests for images and scripts and all sorts of things, but I look through my log and I never see a corresponding get for the HTML that linked to all of those things. So I start going, wait a minute, why did someone have this? This is actually a way that banks will try to detect phishing. They'll see that someone's grabbing their HTML but being lazy and not actually copying all the resources of the site as well. Google respects the robots exclusion standard. And let's be frank, if you're hacking a web app, that's just as no good because it's always fun whenever I'm attacking a site, immediately go to robots.txt because it's basically a roadmap to where you're not supposed to go. So our crawler certainly can't respect that. Google doesn't cache everything. If I have, a script tag and it just references an external, say, .js file with JavaScript in it, which is what MySpace does, Google doesn't cache JS files. So I won't be able to see the entire site. Things can be removed from the Google cache at people's request. You're limited to 1,000 queries a day. Google also doesn't serve beyond the top 1,000 results for any site. So if you search for, kitty cats, you can never see result 1001 for the kitty cats. And also, you're limited by Google allowing you to use the cache in the future. I mean, at any point in time, Google could clamp it and make it very difficult for you to actually access the Google cache. It's just crawling the site yourself is really the only way to guarantee you, one, download everything, and two, that you'll be able to do that in the future. So why would you want to run a covert crawler? Well, a malicious user who's performing a reconnaissance and wants to reduce the forensic trail. A company who's monitoring the progress of another company without leaving a trace. Say, I talked about the IBM patent database here. For years, IBM ran the patent database. But what people didn't seem to see is IBM was running the patent database because they could do a reverse lookup on the IPs and go, wow, Seagate's really interested in these patents. And it's also interested in these patents. And they were trying to deduce what people were working on. It's true. So if I'm Seagate and I want to monitor, the comings and goings of these, researchers that work at IBM, I can keep crawling their personal pages on a repetitive manner, looking to see what conferences they're going to. Just basically, I want to repetitively hit certain information without you knowing I'm interested in it. A lawyer monitoring a website looking for statements that are, nasty on behalf of one of their clients. Miscellaneous intelligence gathering, or you just, you're really, really paranoid and think they're all out to get you. So you covert crawl everything. So, all right, what are the obstacles to overcome? Because honestly, when I thought about covert crawling, I really was thinking about, how can I make a program that I'm writing act more like a browser or more like a computer? And only kind of after the fact, when I actually had written a covert crawler, did I start thinking about what you could do with a covert crawler. It was really, kind of the tail wagging the dog. So the covert crawler consists of a requester, a bunch of requesters, each a thread, that's somehow controlled by a master program. So already you have some fun thread synchronization issues. You have to mimic a browser being controlled by a human, which is not an easy task because crawlers don't act like browsers. And crawlers and humans make fundamental different choices about what links they crawl in the order. And we're going to talk about that because that was one of the hardest things to solve. Multiple IP addresses can be used to reduce the bandwidth footprint. We must control all these threads. Now, here's the interesting thing. We have to maintain session state. If I've got a crawler that seems to be coming from India and another one that's coming from New York, and a website issues a cookie to the one in India, and then the one in New York sends that cookie back, you can analyze your logs and see that these multiple threads are collaborating. So you need to find very, very strict ways to make sure that the person simply looking at their logs cannot tell that all of these people are actually collaborating to crawl your site. And also, the crawler must be throttled not to overwhelm the site. So the first obstacle is definitely acting like a browser. So first of all, does anyone have any questions? We're good?
What about captchas?
Captchas. Very good point. There are some things I actually get to when I'm talking about crawling through leaks. There are some things that, I simply decided not to solve. There are a lot of people who have done a lot of good work on cracking CAPTCHAs. It's also when I get to how does the crawler behave like a human. I mean, people write doctorate theses on this, and quite frankly, they don't pay me that much to figure this out for them. So there are some things I just kind of gloss over and didn't investigate fully.
Pretty secure then, right?
CAPTCHA, I'm not a person to answer that question well. Yes?
Would botnet be a good approach to this?
A botnet could be a good approach, but again, you're still going to be, sometimes it's not, sometimes site administrators don't necessarily care about the identity of who did it. They simply want to know it's coming. And if I see a botnet and I see all these people massively blindly requesting pages and they're all seeming to collaborate and things like that, they're all talking amongst each other, simply the very fact that I'm getting scanned lets me know that there's something's going on. Well, like I said, if they're sharing session state, there has to be some type of coordination. Otherwise, they're all just DDoSing you by requesting a bunch of pages. Ultimately, for a covert crawler to be successful, all of these crawler threads have to report their results back to a central location. You parse this information. You pull stuff out. So trust me, if we get a little further in, I think this will probably be a little clearer. So the behavior of a crawler versus a browser is pretty distinct. Crawlers never visually render anything. So HTTP headers describing the browser's abilities are minimal. Specifically, what I'm talking about is right here. This is a request made by IE6. And it tells you what languages it supports. It tells you, actually, the one for Firefox is much richer. It'll tell you, hey, if you can't get this character set, degrade to this character set. Crawlers don't send that because they never worry about, they never actually visually give you the information. There we go. Crawlers never visually render it, so they don't have to. Browsers are very rich user agents, and so they tend to send lots of HTTP headers. Crawlers really don't have to, so they don't. Crawlers also request HTML and just simply parse it for links. Browsers request HTML and then grab all the supporting files. So, if I'm a crawler, I just grab the index, or I just grab the HTML file, and then use a regex and extract all the hrefs. And then I stick those in a queue and proceed to go. But when a browser grabs it, it grabs the fave icon, the style sheets, the JavaScript, the images. So simply the signature of requests a crawler makes is distinct from the signature of requests a browser makes. So we're going to have to somehow replicate that. Crawlers are also very simple, whereas browsers are extremely complex. They contain code for parsing Java applets, Flash, JavaScript, ActiveX, and the crazy thing is these technologies can make direct HTTP connections themselves. So if I have a crawler that visits, say, an index page, well, that index page maybe contains some JavaScript that uses AJAX. Well, AJAX is a way that JavaScript can make HTTP connections. So if a crawler just requests that page, it's not going to make the HTTP connections that a browser would make, because the browser is going to take the JavaScript, interpret it, and make those HTTP requests. So again, it's just another way that crawlers simply don't make the same requests that a browser would make when looking at a page. So again, I showed the browsers making lots. Covert crawler is going to have to duplicate both the order and the value of these headers. So I picked the most common browser, which was IE6 at the time, and the most common version, and that is the type of GET request that my covert crawler will send. So obviously I needed a mechanism. I wrote this in Java, but I needed a mechanism for manipulating HTTP headers in Java. First of all, anyone here ever done some Java web programming? Not JSP stuff, but writing kind of like Perl LWP, but in Java, because you're lazy and Perl scares you? So this really pisses me off. Java's built-in library, they have a nice class for making HTTP connections for you, and it allows you to specify a proxy to use. Use this HTTP proxy for me. The bad thing is that what happens is if you say, hey, go use this proxy, if Java can't actually connect to the proxy, it'll just make the request directly for you anyway, without going through a proxy. Assuming, of course, well, I should make the best effort to get this resource. Well, of course, if I'm writing a covert crawler, the last thing I want this to do is make a direct request. I always want it to use proxies. So I found a beautiful HTTP library for Java that allows you to manipulate, all the headers. It allows, failovers for proxies. It's excellent. This is really cool. You guys should check it out. Here's a little snippet of code, but basically, I'm replicating all of the headers that a browser would send. Also, we need a mechanism for getting these page resources. Like I talked about, one HTML pages causes several other HTTP transactions. I have images, image maps, scripts, complex media, fave icons, style sheets, all sorts of junk. These are all the sites off of O'Reilly.com, and you see, right there I've got, almost 24 images alone that I need to grab just from visiting the main index.html page of O'Reilly. And that doesn't even include, they have so many freaking like RSS feeds and style sheets. It's ridiculous. So I needed to browserify a crawler. And so basically, this is a dump of one of the log files, but I grabbed, oh wait, I have the laser pointer. So right here, I grab the index page, and then the browser fire, all these red dots are other requests that my covert crawler needed to make to look like a browser. So I'm grabbing a JS file for JavaScript. I'm grabbing a style sheet. I'm grabbing a GIF. And then the rest of these are just a bunch of GIFs. So definitely, you have to make all the HTTP requests that a browser makes. So more browser emulation, because acting like a browser is a lot more than just sending the HTTP requests that a browser would send. It's also how you send them. Browsers use what are called persistent HTTP connections, where basically you leave the connection open, I make a GET, I get the response, and then without destroying that connection and redoing the three-way handshake, I just send an HTTP request. Crawlers typically don't implement this. There are some weird HTTP like pipelining, persistent connection stuff. It's not. A lot of people don't implement it very well, and again, the library really helped me out. So even if you need to, you need to find out whether your crawler even needs to send them, because browsers implement a cache. So my crawler had to implement a cache, because there are certain things like HTTP. Oh, here's the E tag on this. This resource doesn't expire for, till 2010. So a browser would never make a request for this image again. My covert crawler, to look like a browser, obviously, needs to respect all these. You guys can see this gets really complicated really quickly. I have to respect caching controls, respect caching directives, use conditional gets, saying, hey, get me this resource only if it's expired. I mean, this was not trivial to do. Really? Interesting. Well, it's funny because I use IE as my HTTP headers, but I was doing everything in Linux on Java, so I was using Firefox. I was doing a lot of running it through a proxy and then making sure I was doing the same thing. So there are some features about HTML that make browserifying a crawler, so to speak, quite difficult. The HTML can contain objects, like I said, that make HTTP connections on their own. We talked about AJAX already. Flash can use sockets. Java can use sockets. ActiveX can use sockets. You've got meta refresh tags, so other objects will continue downloading. I grab an HTML page which says, hey, refresh to this other page in 5 seconds. But I proceed to download the style sheets and all sorts of other junk. But as soon as 5 seconds happen, I got to go get this other thing. You got timing issues. That's complicated. So obviously, writing Flash and JavaScript and ActiveX parsers were outside the scope of the project, so I just ignored them. So that pretty much took care of making making my covert crawler act like a browser. When it would request a resource, it would request everything else it needed to, the exact same way a crawler would, and respecting all the caching information. Now the tough part was, how do you make the crawler browse like a human browse a website? Because crawlers navigate links and make requests in a very obvious and predictable pattern. They're extremely easy to detect in logs. Humans make browsing decisions based on the content and whether they like it. And not only that is the request pattern is very different from a crawler, but the request pattern is different from person to person. If Akari here is looking at Hackaday, he might be interested in, say, some RFID hacking stuff or some FPGA hacking stuff. But if George is looking at Hackaday, he might be looking for, I don't know, George, what hardware stuff do you like? Porn? Yeah, hardware porn. Whoa. I've talked to Elliot about getting some of that stuff on Hackaday. That'd be great. So, it's how you make the request patterns differ not only from person to person, but certainly from all people and crawlers. The title of this slide really should be Behavior of Computers versus Humans. Replicating human behavior is very, very complicated. And this is not a master's thesis on AI. And frankly, my company doesn't pay me that much for me to, figure this out and solve this problem. So what we really needed to do was find a good enough solution that was practical to make a crawler navigate links as if it were a human. So just real quick, almost all crawlers are what are called breadth-first crawlers. It's really simple. You've got a pending queue, so you pull the link off, you grab the resource, you store a local copy. If the content was HTML, then for each link in the HTML, check to see if it's already pending in the link or if we visited it. If not, stick it in the queue, move on. It's really simple. And you can write a crawler in, say, Perl in about 8 lines of code. And probably 3 if you're really elite. So here's how pages are retrieved by a breadth-first crawler. They use a queue data structure, which causes the crawler to visit all pages of equal depth before going deeper. So I make a request for 1, and then I make these pages before I go to 4, even though I discovered 4 off of 1. So this is a very simple design, and there are tons of examples. This is basically the definitive way you write crawlers. Everyone does it this way. The cons of this, obviously, it's very obvious, non-human behavior. I'm going to hit all of these pages that are linked off the site route before I hit one off of it. No human browses that way. Pages can be requested when the previous response contained no link to the page. I mean, it's just very obvious to see that this is a crawler. Browsing like a human is different because all links for a crawler, all links are created equal. It doesn't differentiate between how important a link is. But some links are more equal than others for humans. For example, if you're looking at O'Reilly's page, this is really interesting, this is really interesting. These things, maybe not so much so, but humans, just we've been conditioned by the way web design has been over the last several years to look for a table of contents along the right side. You're more likely to click these things than you are to click, something over there like more, or at the bottom of the page, their privacy policy. So how the link is presented and its context really kind of signifies how likely you are to click on it. And so this is a problem, because how do you teach an automated process to understand the context of a link? Luckily, some smart people at Google have been working on this very thing. So I actually have read a lot about PageRank, which we'll get to in a second. So page retrieval for a human, like I said, the pattern is completely different than a breadth-first search crawler. Each human will access resources in a different order based on personal taste, and crawlers almost always act the same. Regardless of whether Googlebot is crawling you or Yahoo's crawler is crawling you, they're pretty much going to request pages in the exact same order. That's not entirely true for search engines because they actually keep track of how often a page is updated and visit those more often than others. But basically, the lesson here is link selection is extremely important for a covert crawler. A human, goes down this way and then goes back and goes here. So we somehow need to find a way to do intelligent link selection. So as I said, humans and crawlers see the HTML differently. The crawler simply sees a list of links. So humans filter what links they want to click based on all sorts of factors, all of which we need to try to find an equivalent for. They filter based on positive link content. Is this something the user is interested in? For example, hardware porn for George. Is it negative link content? Not hardware porn for George. He wouldn't click on it. How is the link presented? Is the presentation of the link itself interesting enough to warrant clicking on it? I mean, who hasn't wanted to punch that monkey in the face? Everybody's wanted to punch the monkey in the face. And chances are you've punched the monkey in the face before. So understanding the context of the links is pretty important. We can kind of fake it by examining the contents of the link's text, which is what I did. Understanding the presentation of a link is relatively easy. It's defined by its structure inside the HTML, inside a cascading style sheet. For example, you can tell whether it's bolded, whether its text is larger than the surrounding text. Is it an image link? How large is this image in terms of area reference to their entire screen? You can kind of use these mechanisms to determine how is this link actually presented to the user. Unfortunately, we can't evaluate actual images. There could be an image that's a link, and the image says, never, never, never click on me. This kind of touches on the CAPTCHA stuff you were mentioning earlier. I'm not attempting to analyze images. Doesn't Google have to do all this? I mean, PageRank, link scoring. I mean, this isn't a abstract problem. People are working on this, and there are a lot of interesting solutions to it. I had to choose a very simple solution because, if I had been able to choose the Google solution, I would be making billions of dollars. And I'm not. So I came up with something a little easier. What I did is I would score a link based on numerous factors. And basically, the link score would be calculated, and it would kind of give me a, for lack of a better term, popularity rating for that link. It would tell me, how likely the user would be to click on it. Does it contain emphasis? These are the things I was mentioning earlier. What's the length of the link's text? Both word size and word count matter. So if you've got, if there's a link that just says, download my latest project here, and here is the link, and that's the only word in the link, you're less likely to click on that instead of download the latest version, if that was the link, and that was all underlined. It's simply larger. It contains more information. I also tried to rate the goodness or badness of the words inside the link. So good words would be things like new, main, update, sell, buy free, porn, stuff like that. And I've got a list, and you could tweak it. So every time I'd see a good word, I'd up the link score. Every time I'd see a bad word, who reads the copyright statement or the legal statement or the privacy policy on a website? Nobody reads it. So I had, about, things like that. No one ever clicks on those links. And so a covert crawler shouldn't click on those links because it's trying to replicate a human. So I would decrement a link score if I saw those words. Also, if the image is a link, if the link is an image, what I would do is I would say, all right, well, what's the length and width of this image? Let me take the length of this image, figure out what the area of it is, and what percentage is this area of their entire screen size. Let's assume they're using a 1024 by 768 screen. If I've got a image that's 400 by 200, that's a pretty damn big picture relative to the entire screen real estate. Did you have a question?
Does the crawler take into account that some minimal number of people might click on those links? So if the crawler doesn't click on it at all, would it reveal itself?
It's possible. You have to understand, and I'll get to it when I talk about spreading the crawler. The way the covert crawler works is there are a bunch of threads. And the threads pretty much try to pick the most popular links and visit those first. But every now and then, I will promote an unpopular link to make sure I exhaustively crawl the entire website. But there's overlap. Like if I've got 10 crawl threads, all 10 of those will request the most popular page on the site because it would look suspicious if they didn't. But maybe only one of them, or one out of every 100, will actually request the legal policy or something like that. Because who knows? Maybe there's a SQL injectable form on the legal policy. That would be pretty funny, considering it's the legal policy. Yes?
Have you thought of using Google to just do a search on the site and based on the word they come up and most likely the top page will be the most popular?
Yes. I looked at doing that, and it's certainly something you could do. I tried to make a completely self-contained solution. That way I'm not dependent on, say, some third party to give me information. Now, I do, when we get to throttling, I did use Google to try to determine the size of the site. I used Netcraft, Alexia, some of these other people to try to determine how popular a site is. Because if you've got a GeoCities page that only gets 100 hits a day, if you suddenly get 1,000 hits a day, but they're coming from 100 different people scattered across the globe, that looks a little weird. But we'll get to that in a little bit. Also, if there's an alt text associated with the image, I do the traditional link scoring image on that. So this is kind of abstract. Let's actually show an example. This is O'Reilly.com. And sure enough, you're seeing there was a link to O'Reilly.com, which contained an image, so it got +5. And also the image area gave it +57 popularity points. This one was a link for actually a book. We'll see. And it had, image bonus. It contained the word shop and hot, so it got plus words. Right here we see word punishment. There was a jobs.o'reilly.com. Obviously, if you're crawling, monster or something like that, you'll want to take jobs out of the bad word list. But typically, most people don't click on that little jobs link at the bottom. Your mileage may vary. And here we see a sorted list of the links it found in the scores, and we see things like, it's kind of hard to see, events. I'll show you this on the next page. There's an O'Reilly events. This Safari, that's a book that they're premiering. O'Reilly.com, and actually it kind of sucks because O'Reilly.com changed their web layout like a month ago. But this O'Reilly.com, a link to O'Reilly.com, that big image at the top that said O'Reilly was just simply a link to the homepage. And sure enough, we see it. Here is the Emerging Technology Conference, which had the image and this text is all for the Emerging Technology Conference. That was that little thing we saw for events.O'Reilly. And actually, it was this book right here for Safari that came up pretty high because it's got a picture and an extremely long number of words. So those links, Obviously, this O'Reilly.com link came up. So just like what we saw in the previous picture, all kind of the links we had a gut feel that it would seem like people clicked on, this algorithm does a good job is actually ordering those as popular links. Yes? Now that's very interesting. I'm about to talk about that. Position in HTML is not a good indicator, and I thought it would be. And the reason is, it's not stupid. It's very good. But this mentality of we need to get away from everything that was bad with HTML from 1997 and separate content from presentation. The structure of the site should be different from the content of the site. How we present the site. Have you guys ever been to CSS Zen Garden? Awesome site. See, perfect example of separating content from presentation. Well, because you're separating content from presentation, you're using absolutely position, div tags, you're doing all sorts of stuff. So just because a link appears in the top of the actual HTML file has no bearing on where it will actually be rendered on the page. And that's complex. I mean, I could write, like I said, that's another thing. I could write something that actually interprets style sheets and tries to actually render HTML, but again, really complicated, and frankly, I'm lazy, so didn't get around to it. Style sheets also can make emphasis detection rather difficult. You could declare this. I'm going to say that this is, a heading 6 tag, an H6, which is a pretty wimpy tag when it comes to how it's actually rendered. But I could style that so it's big freaking flashing red letters, and I can declare that style in multiple places. Inline, I can have an external style sheet. I can declare it at the top of the page. I can, have a style attribute on that one particular tag. Worse, browsers are really bad at forgiving badly formatted cascading style sheets. Back when I gave the presentation at TourCon on phishing, I had to actually write a HTML parser in Java, which is not, it's great if people are following the standard, but malformed HTML is really freaking hard to parse. And parsing cascading style sheets, because it can be malformed and browsers will still deal with it, is not trivial either. And again, lazy. So, like I said, you can do it inline. Also, bad words are relatively static. Here's something that I learned. Regardless of what website you're visiting, hardly anyone reads privacy.html. So, some of the things, like I said, you might have to remove jobs or insert hardware porn into your good word list, something like that. Good words can vary from site to site, so you've got to tweak those. And also, you don't want to score links whose target is the current page. This was kind of interesting. O'Reilly, actually, their new web design is a good example. A lot of times people have like a bunch of tabs. Amazon used to have this. Now they've got like 3 tags. But they used to have like 50 tags across the top of the page. You guys remember that? Like books, electronics, all that junk. Typically, the page you're currently on, if they have that type of layout, that tab will be bolded. It will be larger than the others, showing, oh, you're currently at this page. Well, obviously, if you're currently at that page, you need to say, all right, well, if I see a link, if I have a link whose target is the current page, don't bother scoring it, because chances are it's artificially emphasized to try to show the user, hey, this is the page you're on. Also, table of contents style link lists are hard to deal with. Oh, yes. So that was the other thing. The O'Reilly page. We had that table of contents down the right side. It was a bunch of links, but they were all very small and not very long. And so having to deal with table of contents, all those links didn't score as high as, say, the picture for eTech or the Safari links and things like that. Even though it's a table of contents, and it's very likely a user will immediately go to the table of contents, simply because they tend to be smaller. So I never really came up with a good way of dealing with table of contents style link lists. So are you guys good? Am I boring? I can't tell. Feedback? Are we good? You enjoying it? All right. Fantastic. I see that you gave me the thumbs up, and I know you're a hard man to please. So, all right. So most people, what I went ahead to do, how the covert crawler works, is I used a priority queue of pending links instead of a regular queue. And the priority queue was sorted so that, the lower your link score was, the farther down the queue you would be. So technically, whatever link is at the top of the queue is the most popular link that I haven't visited yet. And so when inserting into the queue, the first thing I do is check to see if it exists. If so, I sum the link score of what I found, what I wanted to insert, and what's already there. Now, it's interesting. This is something else I learned. I originally thought I just averaged them, but that actually hurts it, Because consider if I had on one page a very big image, so it had a very high popularity score, linking to, say, shophere.com. And that had a link score of, say, 100. And then on another page, I found a link to shop, and that was just a small little text word that said shop. And that had a popularity score of like 10. Well, if I average them, I'm actually losing the overall popularity of the link. So you have to sum them. Also, the issues of link equality with multiple threads was interesting. When you start getting lots of URLs that have the same popularity score, how do you make a decision? We'll talk about that in a little bit. So as I said, the front of the queue is always the most popular link that the crawler has seen, but we haven't visited yet. So, acting like a human. Well, a human needs time to process what the browser presents. So each crawling thread of the covert crawler must wait a certain amount of time before it requests a new page. I mean, if I'm requesting 1 million a second, or, more realistically, 10 pages a second, no human is going to be requesting 10 HTML pages a second. Unless you, like open up a tabbed bookmark or something in Firefox, but you most likely don't have 10 bookmarks all of the same, website. Unless you're bookmarking your hardware porn, George, I don't know. So obviously, each crawling thread has to wait. And now this is interesting. I wait based on the actual size of the rendered content. So what I do is I take the HTML page, I strip out all the tags, and I say, how much content is actually here being presented? Ignoring images, which of course could be huge. And I just wait, and I say, well, how quickly can most people read in terms of words a second? And so that's how long I wait for. Also, I figured this all out by visiting Netcraft and reading some interesting stuff on search engine optimization about how long an average user will read a particular HTML page. So actually, you can quick these up, because most people are very click, oh, no, that's not what I want, close, click. So people do navigate pretty quickly, but it's certainly not 10 requests a second quickly. Also, this is pretty cool. I gave the different threads personalities. I would keep track of all the HTML pages I visited, and I'd keep a word count. And I would try to deduce, what is this page about? This page seems to be about Apple, or this page seems to be about Intel, or something like that. And so I would give each crawler of the most popular words I found on that site, I would give each crawler thread as I spawned it out a keyword. Hey, if you see a page that contains Apple or FireWire, you're going to spend a longer time reading that because you, crawler thread, you're going to pretend to be an Apple fanatic, or something like that. So the crawler will actually throttle itself, and the different threads will react differently to the same page. Again, just trying to throw entropy in it to make it all harder for the people looking at the logs. So obviously on pages that have keywords, I look longer. Other pages, I quickly leave those pages because that crawl thread's not interested in those. All right, anybody have any questions? We're good so far? This is going to get kind of complicated kind of quickly, so I warn you in advance. Hopefully the graphs will help clear things up, but this is how you actually spread a crawl over multiple IPs, but also maintain things like session state and cookies, and it gets kind of nasty. Yes?
Is there any way, let's say you don't want to crawl the entire site, you only want to crawl specific pages on that site every single day.
Okay.
Is there ways to avoid protection on that too?
I mean, you could just say, here is the page. What you could do is say, here are the pages. That's interesting. I don't have a mechanism in it currently to do that. But what you could do is say, look, here's the site. I've already crawled it before, so I know what it is. Let me bookmark these pages. Now, on a weekly basis, I want you to covertly crawl this website. But once you've hit these pages, you can stop. So it will say you're only interested in 10 pages. Well, the covert crawler on whole probably requests something like 70 or 80 pages. But the rest of that's just noise. All you're really interested in are those 10. And once it gets those 10s, it'll throttle all the other threads down. That'd be a cool feature. That's certainly doable. It doesn't currently exist, but yeah, you could do that. So obviously, we're going to be leveraging open proxies. We have to spread this across multiple IPs, and the last time I checked, I didn't have a Class A. So I had to go find people's open proxies. This is a possible weakness of the covert crawler. It's really funny. There's a guy at SPI Dynamics named Darren, and he developed a tool called Log Alert, which was long before I got to the company. You could basically feed it a server log, and it would try to tell you if crazy stuff was happening, like a lot of requests for resources without a request for the HTML page that links to those resources, things like that. And it would actually try to find out whether you were being reconned or not. And so he and I kind of went through a good 2-week Cold War where he'd say, like, well, I'll do this. And I'd go home muttering, damn Darren. And I'd come back the next day, go over to the whiteboard, and big smile on my face, be like, what about this? And he'd a lot of back and forth. And basically, the only thing we were able to deduce with the final design of the covert crawler was the weakness of using open proxies. The weakness of covert crawler is we're leaving the IP addresses of known proxies in the server logs. And so that was one of the things that his tool would do, is it would take the IP addresses and then check a couple of the known websites that list proxies and see if someone was visiting you through a proxy. Also, the choice of proxies is very important here. Obviously, if we're crawling a U.S. bank looking for vulnerabilities, we only want to use proxies in the U.S., possibly some from Western Europe. There's a wonderful thing called IP to country. It's a giant freaking comma-separated value file that gives you basically IP number ranges and the resulting country. And so I use that. But obviously, you want to minimize the number of proxies that announce their proxies. Normally, when you send an HTTP request through an open proxy, it sticks all sorts of HTTP headers in there, via, max forwarded for, max forwards. I mean, all this stuff that you don't want the resulting site to know you're proxying. So I actually built a little app that would grab a list of proxies and basically connect back to itself through a proxy and look at the HTTP headers and kind of rate, whether it's passing and whether it's announcing it's a proxy or not. Also, sometimes it's not so bad to admit you're a proxy. I mean, the end-to-end internet, as we know it, doesn't exist anymore. I mean, NAT proxies, these are commonplace. And so it actually would look a little suspicious if all of my traffic never came from a proxy. So sometimes using a proxy that announces it's a proxy with HTTP headers isn't such a big deal. So one of the big things I noticed pretty early on, when you've got multiple threads all working together, you have what is called the deep link problem. Basically, I've got two crawl threads, and here's a very simple website, and I've already visited these sites. Blue has already visited these sites. And so I go ahead and I want to spawn another crawl thread, and in my queue of stuff to crawl, I still have C and D and F. Well, if I just out of the blue send a request for F from this crawl thread, it's going to be like, where the hell did that come from? Because really, users navigate to deep linked web pages in three ways. They navigated there by clicking through a series of other pages. They bookmark the page, in which case your HTTP request won't have a referrer header. Or they followed a link from a search engine or something directly deep into your page, in which case you'll have a referrer from a search engine. So obviously, I can't replicate a bookmark. This is also this is very much not the norm. Most people don't bookmark deep parts of your site that happen to talk about a particular product. So for the most part, I couldn't use that. I mainly had to focus on navigating to a page from other internal pages and also doing some fun search engine spoofing stuff, which I'll talk about in a minute. So if green wants to make a request, and I'm spawning a new thread, and I want to make a request for F, green has to first make a request for that, and then F, to try to hide the fact. And that's when I start saying the covert crawler starts making lots of requests it doesn't have to make because it's trying to mask what it's really accessing. So obviously, green requests a page it's never seen. That's a problem. So like I said, IPs that make requests out of the blue look suspicious. The covert crawler never makes a deep link request from an IP address that has no business making that request. So what we do is instead of telling our crawl threads, traditionally the way a multi-threaded crawler will work, you'll have a control program, and it will simply tell a thread, go make a request for this URL. And then the crawl thread will make a request for that URL. Well, shit, we can't do that. So what we do instead is we say, go get this URL. I don't care what you have to do to get it, but ultimately I want you to get the contents of this URL. And the way we have the crawler, each crawl thread know how to do that is we keep a shared graph that represents the entire website. This is where some of that Google knowledge comes in. I mean, Google said, the internet, it's really just a bunch of nodes. And each node has a link to other nodes, which is an edge in a graph. And graph theory is very well defined. There are algorithms that let you find the shortest distance between one node and another. And so if we think of this as a graph problem, it really becomes simple. Basically, all the edges are unidirectional. There are cycles. Page A can point to page B, which points to page C, which points back to page A. Each node is an HTML page, and each edge is a hyperlink. So what we're doing here is the crawl thread knows its current location. And it knows the content of all the pages it's visited. And so basically when the crawl thread is told, hey, go to this URL, it consults the graph and says, hey, graph, I'm here. Find me a path to this URL. And then it goes ahead and makes the request for the pages along the way. And so it gets to the desired resource. So like right here, if green and blue are my crawl threads, and green is at E, green is right, or blue is right here, and green is at A, and I'm told to go get F. Green is told to go get F, so green consults the graph and finds that the shortest path to F is going B, E, F, and so it goes ahead and makes a request for B, even though we've already requested it with this other crawl thread. In terms of our grand scheme of things, we already know the content of that page, but we go ahead and make the request anyway. So we request B, E, and then we request F. So we made 2 requests we didn't even have to make just to try to mask what we were really interested in. So as I said, the key here is to use a shared graph solely for finding the path to the links. You still have to keep session state on each crawl thread. You know, if I give a cookie to this crawl thread, that cookie can never be shared with other crawl threads. The way we do this to finding paths through the graph is we use a modified breadth-first search to find paths inside a graph. Without getting too complicated, you know, typical. If anybody has the MIT white book, there's a lot of stuff in here on this. But normally you use either a stack or a queue to find paths through a graph. And the thing is that always gives you the shortest path. And so I determined, well, you know, possibly someone analyzing logs could say, this crawler thread always seems to find the shortest path between this HTML page and this HTML page. Let's say to go from, you know, main.html to porn.html, there's a really long link through like 10 pages to get there, or there happens to be one link in the bottom of that legal policy, because nobody ever reads that. You know, we don't want it to take the shortest path. We want it to take a reasonable path. And so what we do is we use a random collection instead of a queue or a stack. So we actually just say stick nodes in, pull them out, and this actually gives us a reasonably short but kind of random path through the website. So if I'm here, I will kind of, and I want to go all the way over here, I'll kind of find just, it's not short, not too long, a path to get me there. So since the graph is unidirectional, it's possible there isn't a path from where the crawling thread currently is to the destination. But remember, our crawling thread is acting like a browser, which has a back button. So what it does is it says, let me go back. Let's go ahead and say that there wasn't a link from A to B, and green was at A. Well, green can always hit a back button, and when I go here and I don't re-request the root, I would respect all my stuff that's been in the cache. I would send maybe conditional gets to see if I need to make this request again. Then green would send a request for B, E, F. So you can implement a back button. So, all right. So moving along. Anyone have any questions on that? We good? Yes.
Like my previous question where I said you just need specific pages, right? Like you're really talking about you crawl a site once and that's it. Let's say crawl a site once, you store the graph that you use for all those links to the site. Would it still be detectable as if since you need to hit that site every day, randomly create paths based on that graph you already have set?
You could do that. Yeah, I was using this as an initial one-shot reconnaissance. You could obviously optimize this if you're only interested in certain pages. You could basically say, I've already got a graph. I already know the link structure of the site. Find me a random path from the main page to the 10 pages I'm interested in. Spawn 10, maybe actually spawn 15 crawl threads. That way they overlap a little bit. And these 15 threads, get me those 10 pages using random paths. And do that on a scheduled basis. Yeah, you wouldn't necessarily have to do the entire thing. I was mainly focusing on, let's do an exhaustive analysis of the entire page. But if you want to do repetitive stuff, you could obviously optimize it. Anybody else? We're doing OK on time. I know there's a break after this, but I will hopefully not go more than, say, like 5 minutes into that, because you all want cookies and milk and other fun stuff. So HTTP is stateless, in case you didn't get the memo, which means that web apps have to keep state using other mechanisms, mainly cookies and sometimes in URL session state. In URL session state is when you see something like this for sites that don't have their cookies turned on. So we must ensure that session state associated with one crawl thread that found a link doesn't get resent by another crawler. Obviously, since the crawling threads don't share cookies, we're OK there. The cookie that this crawl thread finds never is going to be resent by this one because they're keeping their own cookie cache, just like a normal browser would. However, crawling threads that have, or when there's in URL session state, that's a problem because this crawl thread finds this link, and the link contains this session state. I need a mechanism of one crawl thread going, I need to go to this page, but I can't use their in URL session state. I have to use my in URL session state. Don't worry if this sounds confusing, because it is, and it's easier to see with an example. Just know that, again, the graph and the paths through the graph is what helps us here. Since a crawler never directly jumps to a target page, but instead follows the path to get to that page, we will find our URL session state along the way. And you really need to see an example for this. So let's go ahead and say that we've got this same website again, and that blue has visited the root, C, and E, and green hasn't even done anything. And so my list of pending links that I still need to visit are B, F, A, and actually D, but D is not popular, so we don't care about it. So the graph's nodes, as I said in this graph, when each node is a URL, the URL that's for oh, never mind. Green is spawned and told to go to B. So B, because that's at the front of our queue that we would visit. We already know what the URL for B would be. We haven't necessarily visited it yet, but we do know that we know what the URL for it is. However, the URL for B that we know about, it's polluted with the session state from blue. So if green makes a request for it, it's going to be using blue session state, and that's going to be corruptible, and you're going to be able to tell that the two threads are collaborating. So what we do instead is we go ahead and we spawn green, and we tell green, hey, go to B. So green goes ahead and it looks at this entire graph and says, well, to get to B, I make a request for the root, and then I make a request for B. So green goes ahead and makes a request for the root, which obviously has not yet been polluted because the root is, like O'Reilly.com/index.html. It's known. That is not polluted, but all these other pages are polluted. So what happens is that green makes the request for the root and it gets it. Now green knows that the root is going to have some link to B, and it knows what B looks like that when it's polluted. So but like we said, it knows what the link to B looks like, but that link that it knows about contains it contains blue's session state. So what green does is it looks at its copy of the root and says, find me all the links that have the same, it basically diffs the links. It says, I'm looking for a link to B. Hey, all the links that are on this page, find me the link that most closely resembles the URL I know about. And the difference between those links will be the in-URL session state. Got it? Good. All right. So we scan all the links. We go ahead, and green looks at a diff of the links, finds the link to B that will contain its session state. Green can now make a direct request for B, and it will contain green's session state. And so we have solved the session state problem. Yeah.
Continuing crawling, so you don't have to continually do that. So now, like, one thread can say, like, now, doesn't the upcoming threads can say, oh, I know that the session state is going to be, a variable of SID, so I'll just, put that in there.
You could. I mean, all that really would do, remember, the crawl threads, it's not like we're doing a special case of find a path through the nodes, because we always have to find the path to get there. So all that really would do is reduce the amount of time it would take you to, do a diff of all the links, and we're having to throttle ourselves to be acting like a human anyway. So it's like you could optimize it, but all you're really doing is, increasing the amount of time your CPU is just going to sit there being idle before it has to make the next page. So it's a beautiful thing about this. It works so well with my laziness because it's supposed to be lazy. Because if it's quick, it won't look like a human. So it worked out well for me. Anyway, I'm showing how if green wanted to go to F, it can just keep going along the way, finding its session state. Basically, if you guys got the whole thing about diffing it, you've got this concept. So the conclusion about path to pages is that any link... Well, never mind this. All right, so crawl threads, the big thing here is that crawling threads have to overlap, right? If you've got 100 pages and I spawn 10 crawl threads, and each crawl thread only gets 10 pages, and they're never the same pages that another thread got, looks a little suspicious. So there is always overlap. We always use a path to get to where we're going to help resolve the session state issues. And really, it's the only way to make it appear as if there's actually a separate user on each separate IP. It's really the only way to make it look like no one is collaborating with anyone. Yes?
So do you know what kind of tools you're up against, so to speak? We're trying not to leave obvious trails in the logs.
Well, that was great that my company wrote a tool to do exactly what I was trying to defeat.
Log alerts and your buddy's tool. I mean, obviously there's some sort of other thing doing correlation, some smart.
Yeah, they will simply. I actually deliberately didn't look at log alert source code because I didn't want to know how it worked. I simply asked Darren, what does it look for? And then tried to counteract everything it would look for. But it's my understanding what it would look for is let me find groups of requests that, even though they're coming from multiple IPs, in terms of time, they occurred at the same time. All right, well, let's look at what pages were requested by these supposedly different IPs and see whether the requests seem to be coordinated in any way. Like, is there any overlap in their requests? Are they hitting completely different things? Are they hitting, it would keep track of what the popular pages are. Are these things hitting the popular pages? They're not. That's kind of weird. It would look at, hey, what's this IP address? Is it an open proxy? Are all these IP addresses, maybe they're different IPs, but they're in the same block owned by the same company? Things like that. So, just really quick, alternative with path to pages. As we said, the other way someone can get to a deep linked page is through a search engine. So what I could do is the covert crawler can create fake Google refers and directly jump to a page. So let me just show you real quick. Ignore all that text. Let's say I want to make a request for F. And sure, I could spawn green and have it, take maybe this path or maybe this path or, whatever. I could do that, but that means I'm sending a lot of requests I don't have to. What I could do, since I've already gotten E, I know about F. Oh, and one thing, if you guys haven't been able to tell, the leafs on your graph, those are pages we haven't visited yet. Because if we visited them, we know there are links off of them, presumably, and obviously it wouldn't be a leaf node. So if we want to go get F, we don't know the contents of F, but we know it exists. We do know the contents of E, so we just do that modified looking for keywords. We say, hey, let's do a keyword word count, find out what E seems to be about. Great. Now let's have green make a request for page E and set its referrer header to look like it's being sent from a Google query. So we'd say googlequery.com, the keyword that we've associated is with E. And so basically out of nowhere, E would make a deep link request, or green would make a deep link request for E using a fake Google referrer, and then proceed to make a request for F. So that's a way you can kind of get around having to make a lot of requests you don't have to. So real quick, some throttling issues. We need some mechanism to determine how popular a site is. Because, if you get 100 people a day, obviously we don't want to be hitting you with thousands of requests. So, there's this fun thing called the IP fragment ID, which Fyodor talked about in How to Own a Continent. Basically a mechanism of determining how many people are connected to a server based on the IP fragment ID that's returned if you're using, say, hping or something like that. We can do a whois to find out how old the site is. We can use archive.org to find out how often it's updated. We can use Google to find the number of inbound links. You can always say, hey, show me the pages that link to, tourcon.org. We can find, not that I'm advocating you guys covertly call tourcon.org to exploit them. We can use Google to find out what the size of it is. We can use Alexa or other services to find out popularity. This is all really kind of a pain in the ass. First of all, there's no standard about how the information of whois is returned. This is really fuzzy and nasty, and I'm still refining it. It kind of works and kind of doesn't. One thing is traffic escalation. Now, this is just fun. So a site receives an order of magnitude more traffic than normal if, say, it's got linked to from a big news story or a blog. If you've ever been slash-dotted, I run a Magstripe project called Stripe Snoop, and I got slash-dotted once. And this were the page views very early in the project, and then I got slash-dotted, and that was like in one day. Holy shit. So, obviously, if I could escalate the traffic of a site, I could kind of hide a covert crawl inside the buzz of all these, people from Slashdot that are coming. So, obviously, do we still need to be covert? If we focus on throttling the crawl back to match the site's traffic patterns. But if it's getting flooded with far more traffic than it normally gets, those traffic patterns aren't relevant. We can increase the speed of the crawler. We can increase the number of crawl threads that are appearing to be users. We can do all sorts of stuff and increase the number of pages each crawl thread visits. There are lots of things we can do.
Do you have an extension in your crawler that actually submits Slashdot stories?
I'm getting to that. So obviously, the covert methods still need to use. Just more traffic doesn't negate having to emulate a browser or intelligently follow links. We can't suddenly unleash a breadth-first crawler just because I happen to slash dot you. but we certainly can increase the speed, and this is certainly helpful. Well, how do you predict a flood? I mean, how do you know a site's going to get traffic escalated? Well, you can ask why traffic escalation happens. It tends to happen if a link appears on a popular site to a relatively less popular site, escalating the traffic. So a major news site or a blog has an RSS feed, thousands of people are reading and suddenly say, hey, here's a really cool link, go check this out. Or it goes out on a mailing list. So, I wrote a very simple agent that subscribed to a bunch of RSS feeds from major news sites. And what I would do is I would scan the stories for links. And then I would check Google and Alexa and try to determine what the popularity of that site was. And I just kind of had a rough guess of, okay, if it's a pretty unpopular site, chances are they're about to get pretty heavily assaulted by traffic, assuming it's interesting. Now, this is not very good, and it was kind of a crappy tool, but it worked. It did a pretty good job of kind of saying, wow, this is about to happen. Now, the only problem is that, my tool got the RSS feed when the thousands of other people got the RSS feed. So it's like, it wasn't so much a predictor of traffic escalation. It was more of, holy shit, traffic escalation is happening right now. And also, it didn't let you pick who you wanted to crawl. It just kind of said, hey, these people are about to get escalated or are being escalated. Do you want to, you should probably crawl them if you feel like it. Well, how can you cause traffic escalation? Sometimes traffic floods need a little bit of a nudge. So what you could do is find an interesting site and some interesting content on the site you want to crawl and then submit to a popular news story and see if they pick it up. Sometimes you've got to blow up the dam to make it flood. And the way I would blow up the dam is find a cross-site scripting vulnerability in a major news site like CNN.com, because there are a lot of them. And then cross-site scripting exploits are everywhere. And you just do a very simple one that allows you to reflect something into a link. So I can send you a link, and when you click on it, not that I've polluted the back-end database, but simply the URL itself has something that's reflected back into the page. And almost always I reflect back into the page a little block of script, which accesses another site, and on that other site I'm containing the content of the story I want to have. So I quickly, whip up an inflammatory article, Bill Gates sucks it or something like that, and is the suck. And then I submit it. And I sit back and I watch the flood happen. As, thousands of people are like, well, no, I seem to think that he sucks it only in this way and not in the way you said. Come on. If there's anything that Slash.nerds love to talk about, it's what way things suck and to what degree things suck. So, you just kind of play with them a little bit. So, yeah, escalating of traffic, or, intentionally causing a traffic escalation is fun. All right, so real quick, implementation of a covert crawler. So I wrote this thing in Java. It emulates a Windows XP Service Pack 2 IE browser that has JavaScript turned on but Java turned off and doesn't have a Flash parser. Yeah, exactly. Except for it renders much better. I don't even have a visual interface, and it probably renders much better. This is a funny side story. So I actually met a couple people from the IE7 team, and I'd had a lot to drink. They came down for this thing in Atlanta called SIP, which is like Security Industry Professionals, but really it's SIP, as in take a sip, because we hold it at a bar each month, and it's really just people in Atlanta who are in the security industry drinking. And I'm pretty sure I told him he deserved a kick in the nuts for IE, because I was like, you guys disbanded the IE division, and it's only because of Firefox that you guys even exist anymore. And this was a big guy, but luckily he agreed with me. He's like, no, you're right. It was our bad. So anyway, I use link scoring to make link decisions. Multiple threads spread across multiple IPs. I use a graph. I create a graph of the site, and I used a modified breadth-first search of the node to find random but reasonably short paths from any one node to another node. The session state issues are resolved because I don't share cookies, and I diff the URLs to avoid in-URL session state issues. I use personalities to determine how long a page should be viewed, and also that kind of ties into the keywords of the link scoring. Source code should be released soon. I kind of was doing this on the side. I have a really fun position at SPI. They're just like think stuff up. And they're like, have it be web stuff, but it really is kind of a blank check to do what interesting web-based research I want. And so I did this, and I kind of said, hey, I'm going up to this thing in Atlanta called ShmooCon, and the VP of engineering is like, Shmoo, what the hell is this? He didn't know what that was, Beetle. He thought it was a noise you made while you were... snarfing out. So I had to explain, and actually really funny, he went to the ShmooCon website, and I guess maybe he didn't have his glasses on or something. He thought the ShmooCon logo with like the shades was actually a woman's chest. Like it was a chick. Like it was a chick wearing like a black bikini and a white belly, and like because you got the nose for the shmoo thing, and it was like the belly button. He's like, there's a chick in a bikini. I'm like, no, that's like this moose seal shit. I don't know what it is. It's the shmoo. So I had to, after explaining to them what ShmooCon was, they're like, yeah, sure. And then I demoed this presentation, and I actually showed them the covert crawler. They were like, holy shit, you can't release the source code to that. I was like, oh, man. So I'm working with them on them. I'd say you got probably 70-30 chance, 30% chance they'll actually let me end up releasing the code. But luckily, I basically told you how to write your own. I mean, seriously, it's not that complicated. If you buy me a beer afterwards, I'll totally spill my guts. So are you still filming this, by the way? You can blurb that, right? All right. So anyway, final thoughts, because I've been keeping you here. Real quick, sanity checks. You brought this up. Someone doesn't have to crawl the entire site. Just the interesting stuff to learn the methodology. That's totally wrong. I don't know why I said it was only 200,000 pages, because I just did a crawl of them last week, and it's 800,000 plus. But CNN has all those pages, right? Well, there are really only a few interesting things. A stock ticker, a story content system, email alert, search engine. A malicious user really only needs a few samples of each to go, you know what? There are some interesting things here. I see that there's a page here called, error.php or something, and it takes in its query string error equals, could not find the page you were found. I wonder if that string of text could not find the page you requested is ever reflected back into the page if that's cross-site scriptable. Or, I see a page called story.php, and its query string is ID equals, and it's always an integer, and it's never negative, and it's never larger than 4 billion. I wonder if that's a primary key in a database. So, you can normally, by applying a little bit of logic, you can pretty much quickly figure out where the parts of the site are vulnerable, and you may not need to grab everything. And that gets into the exhaustive search versus intelligent search. So, yes? How so? Like, no, I probably should have. I probably should have had some mechanism of, hackability. Like, this page has, form inputs and contains query data, and it's actually not a bad idea. You get swag. You can have anything you want. Actually, I haven't been giving out swag. You guys just take this stuff. It's good. Beetle, you guys do good work, but I don't really have a use for this, and they work so hard I couldn't throw it away. So if you've got here. Yeah, it's but the funny thing with my boss is I have no idea what he thought these whiskers were. Whoa. There you go. So everyone come up for their swag. I'm not going to do that again. So in summary, crawlers can be programmed to send requests just like a browser does. Crawlers can make intelligent choices about what links they should follow. That mimics human behavior to some extent. Covert crawlers can be spilled across multiple threads and IPs without revealing that there's a mass crawl going on, that all these guys are collaborating. Session state can be handled, so that's not an issue. Throttling is tricky. I'm still working on it, but it can be done. Increases in traffic can hide any mistakes I happen to make in my algorithm because, if you've got 100,000 people visiting you or whatever, it doesn't really matter that I might have had a little problem with my algorithm. Hold on one second. Proxy selection is a possible weakness in the system, but it can be mitigated by trying to pick intelligent proxies. If I'm crawling a bank from North Korea, that's a pretty big red flare right there. So what you should take away from all of this, you can't rely on your web server logs. You really can't. Because, you can't rely on them to tell you whether you're being scoped out as a target simply by looking at traffic volume. You can rely on your logs to see if an attack happens because, you can always see that, holy shit, the web server did actually receive, a SQL injection attack. But you can't use it to tell you whether a single user is routinely grabbing large portions of your website. And you can't use it to reveal who's been testing you after you discover an attack, trying to find that reconnaissance, because we can hide that. And logs are simply a passive defense, and you need to stop being passive. So the funny thing about this is if you fix your web vulnerabilities, it doesn't matter if they covert crawl you, because you're not SQL injectable, because you use a regex. You use parameterized queries instead of concatenating strings together with user input to create a SQL query. I mean, there are ways you can mitigate this stuff. You can't prevent someone from covertly covertly crawling you. But you can certainly make the fruit of that covert crawl worthless. So, anybody have any questions? Yes? No! Here. I'm going to hold this till the end, and if you're very good. Yes?
How do you determine the good words?
I just kind of... I could tell you some super secret scientific method, but I just kind of sat around drinking one night thinking of what are fun words I like to click on, like XXX and porn or something like that.
What about using the meta tags?
You can pull meta tags out to use to pull out the keywords, but I mean, I guess I could do that to have it like a feedback to dynamically change what are good and bad words.
Right, so when you're a monster, you can remove jobs from that.
Right. That's not a bad idea. Yes. The lady in the hat.
Thank you. I don't want to challenge you or make you wrong.
Please, by all means, do.
Well, you just kind of said that you can't do something with this, but can't you use what you developed here to actually be proactive as opposed to being reactive? And that's kind of what I got from the last part of your talk, is that you have to be reactive. Did I not get something here?
I would be interested to find out how you can use a covert crawler for anything. I have to quote The Simpsons and Professor Frink when he says, well, to be honest, the ray only has evil implications. If you could think of a way that it could do good, more power to you, but I didn't bother.
Well, no, actually, I would ask you, I really, really would challenge you. How do we in the community who are actually implementing this stuff, use this to be proactive as opposed to being reactive?
Use it as ammunition to get people to write better code.
Yeah. There, he took care of it for you. There were lots of hands. I think you had your hand? Yes.
You can flood the site and make it look like it's a slash flood if your refer looks like if you're all coming from the slash flood.
Certainly you could. But, it'd be true. Again, they could just go... Yeah, they could go to see if it's actually on /dot. I mean, certainly I didn't cover everything you could do. That's not a bad idea either. I like that. You can get swag. Yes?
One of the positive things and proactive things I got out of this is not necessarily the crawling part, but the scoring part.
Yeah.
And the AI part. Hopefully you get it up. I want to take that piece and use it on our website for our marketing department so they can understand how the interface is crappy and maybe make it better.
That actually was the fun part of this. Is I got halfway through it, I'm like, wow, what I'm really kind of doing is I'm trying to take a site and figure out, derive meaning from it, which is exactly what those slimy search engine optimization people do. And so when I created this, here's the graph representing your website and how interconnected it is, I can determine metrics like how easy is it to get from this page to this page? How obvious is it to your users based on the size and presentation of their links, how they navigate? I mean, there's certainly other implications, and to be quite frank, that's what my company was most interested in, was the link scoring and the using the graph and determining popularity as we go. I pretty much told you the algorithm that I used. It's not very complex. And if you give me drinks, I might actually show you the Java code. It's very trivial. Go through a word list. If the word's there, increment a score. It's pretty simple. Yes?
While covering up your tracks is really nice, isn't it the easiest way to do so to just use your next door neighbor's open access point and do all your crawling from his IP address?
You could, but the point of this is I didn't want them to know something was imminent. Everyone does reconnaissance before they attack. And if I suddenly know that I notice, I'm a really anal sysadmin and I have something email me in a cron job, if a log is too large and I'm compressing it, I'll be like, holy crap, I just compressed my log. Why is today I'm doing it again? Let me go investigate. I just wanted to show that, you don't know anything's coming. But certainly you can go to your neighbor's access point and, do whatever you want. Get your hardware porn or something. Yeah, I'm going to take 2 more questions, and then you guys have already been very good. Sorry, Noid, I don't mean to run over. I'll tell you what, I'll do 1 more question, and then you guys can talk to me afterwards. Does that sound good? Who has a very good question?
What kind of drink do you like?
I like Heineken.
That's a
Very good question.
All right, that's a good question. Okay, I'm done.